Cool.
Hi everyone, and welcome to OpenMind's AMA, Ask Me Anything. OpenMind is an open source community focused on making the world more privacy preserving. In this AMA interview, you'll have the opportunity to ask questions of privacy experts from OpenMind community. My name is Emma Salemi, and I will be your host for the day. First, let's introduce our guest today, Maddie Shang. Welcome. Hi, Maddie.
Hey, how's it going?
Cool, thank you. So Maddie is a Federated Learning Fellow and RecSys team lead at OpenMind. She is an industry AI research engineer based out of Cambridge, MA. She's currently focused on deep probabilistic models for unsupervised knowledge representation and meta-reinforcement learning. Her research interests also include machine learning for healthy community marketplace growth. When not working towards interactive and reasoning machines, Maddie is working on diversity and inclusion in tech, entrepreneurship, advises startups, and goes on adventures in the wilderness and the pilot airplanes. Maddie founded, built, and scaled Women Who Code Data Science from 0 to 2K plus global data professional members in just 1 year, and is leading the bootcamp efforts at OpenMined Education. She's also a frequent guest speaker on AI topics for Microsoft. Prior to tuning her focus on machine learning, she studied mathematics at the University of Waterloo, completed CFA Level 3, taught herself programming, and worked in tech as a VC. 2 times founder and a blockchain engineer. Welcome again, Maddie. Thank you for joining us for today. We're going to have a session which is federated learning using reinforcement learning, right?
Yes, that is what we're going to talk about today. So maybe a little bit of background. So this is a part of the work that's being essentially part of the PyTorch grant, and basically a team of us worked on a bunch of worker libraries, and you heard Patrick and Varu and Mark talk about this already. And I was kind of working on various things, including PyGrid, PySift, and helping out with the worker library. And part of the thing that we wanted to do is, now that we have all these like awesome libraries, let's actually try to make it do something useful, right? Something interesting. And that's kind of how this idea and this demo came about. So what I'm about to show you is essentially like a you can say like an application we built on top of the worker libraries. And the idea is that we just wanted to show people that, hey, like even though this is an open source library, even though we're still like growing fast and in early stages of development, we still have the ability to build like really interesting products using the system, right? So yeah, so that is kind of what we're going to show today.
Okay, great.
Yep. So what I'm going to do is share my screen. Give me 1 second. I'm just getting everything set up.
Cool.
Okay, yeah. So
okay, we can see your screen.
Awesome. This is yep. Let me go to the first slide. So what we did is that we tried to build a reinforcement learning agent that like is very simplistic, but it learns how to essentially adjust itself according to user interactions, right? So the idea is that it will start to learn what users prefer and actually start to essentially navigate towards those like preferences automatically, right? So what happens is that if you look at like things like Spotify or Shopify or even like eBay, like certain people prefer certain UIs, and certain options will lead to a better like end result or click-through rate. And this is something that we can actually try to optimize. So the goal is to build and launch an AI-powered website that learns and optimizes its own UX over time using the worker libraries, and that's kind of what we ended up building. So use cases that, let's say I'm a dev and I build a really awesome thing. I think it's like great. And then so what's left to do is that essentially try to launch it into the world. And frequently how you do this is that you set up like a landing page, or you just ask people to sign up, or you ask people to sign up for subscription. And at this stage, a very common thing happens is that your UX team will say, hey, like I am very sure one option in this entire list is the best option, and that will have like a really good click-through rate, for example. Except right now, like we don't know which one, right? So if you look at like how we set up these options, there are some options for how you want your background to be, and then there's some options for how you want your button positions to be, and there's some options for like icon and like like button color and etc. So when you essentially multiply out all the options, you actually have like 24 possibilities, and this is what we call essentially cursive dimensionality. So at this point, if you're like an experienced data science person, you're probably thinking, okay, yeah, let's do A/B testing, right? And that is a good instinct and not a bad choice. Except if you were to do traditional A/B testing, let's say you had like 240 users you're willing to kind of expense to do this test, so you can get like statistical validity and etc. That means if there's only one good option, pretty much like 230 of them got like not a good option, right? And then what's interesting is that in some cases, this cost of a user is actually very high because I think in like a just like a rough calculation, numbers floating around the internet, per user value, like lifetime value of each user on Amazon is actually like $600 or so. So if Amazon were to essentially like run this test and do A/B testing, they're actually losing a lot of potential revenue, right? So we have a better way of doing this, and that is through something called essentially a bandit, right? So this is kind of like how the model set up. And once again, this is very simplistic because we wanted to run fast and we wanted to work well in a low resource environment like the browser. So each click-through rate is set up as a Bernoulli random variable. All that means is that you're flipping a coin, and sometimes the coin may not be fair, right? So maybe this is a weighted coin. Some coins are weighted 80% on the head side. Some people are weighted like, say like 20% or sorry, 60% on the head side or tail side, right? So you're just flipping a slightly weighted coin. And because we don't know which ones the users actually prefer before we start out, we're just going to initialize with like uninformed beta priors. Basically, we're saying, hey, we really don't know what's good. We don't have a good guess. So here you go. Tell us what is good by, essentially allowing their users to interact with this browser, right? The benefit of using this algorithm is that based on user actions, it's going to update itself using the beta Bernoulli conjugacy. And this is actually a very simple and very fast calculation. All you're doing is essentially like addition, subtraction, maybe some multiplication. So this is why this works extra well in an online setting in a browser that is low resource, right? And then the other cool thing we're doing is that we're actually using Thompson sampling. So the benefit of this is that this has been shown to empirically reduce regret or opportunity cost in a pretty old neuroscience paper. Not only is it empirically proven, I think people have since then proved the theoretical bounds to say in a essentially a like binary setting, like did you click or not? This is close to the best way to figure that out. So then let's talk about this idea of like what is regret, right? Regret is just a technical term, and I think this is like one of the better named mathematical terms because it sounds like it is exactly the way it sounds. So let's say you already know which option is the best, right? Let's say I have 24 options. I know option number 1 is the best. Then in this A/B test, right, I can actually just send all my 240 users to the best option. And assuming they all click through and assuming they all like end up spending $600, I just made a bunch of money. But if we are just doing this as a normal A/B test, that means like maybe 230 of them would be sent to a bad option. And assuming the bad option gets like 0 clicks, that means we just like, we regret having to lose like 230 users and their like potential spending, right? So that's what we mean by like regret minimization. So at this point, I think we should flip over to the browser. So, this is a kind of an example landing page, right? You land on it, looks good, pretty cool. Let's try this again. I don't think like you will really notice any difference, right? I'm just refreshing. But had you not seen this website first, you would notice that we actually changed the UI, right? And the UI is actually going to change pretty often right now. But then, so let's talk about what's actually happening in the background. What's happening in the background is that you're actually running a model that we pulled from PyGrid. And then what's happening is that based on these models, it's going to kind of like present you an option. And right now it's like particularly confused. It's gonna keep changing its own like options. And you can see here, like we select option 15, we do this again, it's gonna like change to something else. Now it's option 6, right? So you can see some of the variations what we're testing. Right now, this will be like dark background, blue button, and sign up at the bottom. And let's try something else. This will be like that dark background, sign up button at the bottom, but like a like gray button. And this will be like kind of like more colorful one. So anyways, the point is that like this UI will keep changing, right? So what happens is this is actually like capable of interacting with like learning from user interactions. So we land on this, right? Let's say we land on this like particular version. And I actually like this because it's colorful. So I'm gonna click on it, right? So notice after I clicked on sign up, a bunch of things happen. What it said is that, hey, we actually recorded a positive interaction. Positive interaction in this case is just a positive reward saying that the user clicked on it and therefore this is what we want. So right now the rewards are binary, it's either 0 or 1, but you can imagine in the future multiplying the reward by how much expected value this action has. For example, in the case of the e-commerce company that's doing really well, you can say 1 times like 600 for the potential user value, and this is kind of like what the RL agent is optimizing for, right? But something interesting happens when we kind of like learn from user interactions over a long period of time, and this is something I'm going to show you now. So what I'm going to do is actually bounce around a little bit and switch to a notebook. This is the notebook that allows you to essentially define the algorithm that you want, define your plan, and then put that onto like a PyGrid instance. And then PyGrid will then serve the model to all the browser instances who's kind of listening for this model. So all you have to do is essentially run this. And here's where we're defining the plans. And here's where we're actually putting this on PyGrid. I'm going to change the number a little bit because I already uploaded that model before, and it's not going to let me do that again. So you will see that this model-centric hosting of this model has succeeded. So why did I have to change this number? That's because this already exists, right? So let's say like if I do like 3, it's gonna say, hey, like this already exists. We're not gonna let you like override a model, and that's pretty much it. So then let's look at how simple the update algorithm really is, right? So what I actually want to show you is just here, right? This is a plan that we kind of like essentially turn into a series of computations, and here are actually like all the options that you're doing in this calculation, and it's like very simplistic, right? So this is how we essentially load the model into PyGrid, and this is actually what this is listening to. So that is good. So then let's talk about the experiment, right? As people keep interacting, we're gonna expect to learn from user preferences. So we're actually like, I got sick of like clicking buttons and not clicking buttons. So what we're going to do is actually just run a simulation instead, right? So here is how we're going to do that. So bunch of setup and going over to here, we're going to essentially request the model version that is like basically uniform, right? And I'll show you what this looks like. And what we're going to do is kind of like simulate a randomly generated vector of user preferences. Here, what I'm saying is that I don't know what user preferences are, but just make a bunch of random numbers. But I want you to set one of them to be like the favorable option. And then let's actually run this. Yep.
Yeah, Maddie, just a quick note. Can you please like increase the font size?
Sorry about that. Okay. How's this?
Yeah, cool.
Okay, great. So we're just gonna like run this experiment. So as you can see, like at the beginning, nothing's really like more or less better than the other, right? But as we're kind of learning from user interactions about a few hundred data points in, we start to realize, hey, like option 2, the one that we chose to be favorable, is actually like doing leaps and bounds better than other options, right? So essentially, this is kind of what the algorithm is learning, right? It's still going to occasionally explore the other options based on the distribution, but this is pretty much what happens. And by the time we're very sure like option 2 is the best, if we were to essentially reload this model again, go back to the browser, right? So let's try this again. We do still expect quite a lot of randomness, but we do expect it to have like kind of show a convergence behavior. For example, it's going to start to show option 2, the one we have selected, to be favorable more often. Okay, so this is like currently not quite happy with me. Let me try to fix this. Yep, so here we are.
Nice.
Yeah. So the cool thing about this is that, what happens if we wanted to add a new option, right? That's not hard, because what we can do is essentially just say, hey, previously we had 24 options, but we want to essentially add option 25. This is a common situation in like, product testing, right? And then in a lot of the other cases, this would mean you have to start from scratch again. But in this algorithm, we don't have to, because we can optimistically assume that option 25 is just as good as our most favorite option right now, right? And what that happens is it will quickly figure out, the new option is actually not better. And what you will see is that the peak of the distribution will start out like around 15 and around like, around like 0.8, but then it will slowly drift towards like say 0.6, 0.4, and 0.2. It will eventually find its truth. I think it is actually not like as good an option as what we found to be favorable, right? But then the other thing is that what happens if like user preferences changes, right? That's also a thing we can do by essentially just continuing running this algorithm. Eventually, what's going to realize that option 13, for example, has a slightly better preference, a slightly better click-through rate than option 2 previously, and slowly it's going to start to favor that as well, right? So these are some of the benefits of like running an algorithm like this. So let's go back to the slides. Yeah, this is kind of what we did. We generated a random preference vector to simulate like roughly 200 users. I think the one I showed you may have like more users. And we're going to generate the random vector, like we mentioned, and then we're gonna like essentially artificially simulate positive or negative outcomes based on the above. So when you're looking at this graph, what you're trying to figure out is this both shows you the level of confidence about which option it thinks is preferable, but also it shows you what it thinks the mean of the distribution is, right? So if you look at the final result, it became very confident because we have like this is much higher and more peaky of a distribution than all the other ones, because as we're finding out option 2 is better, we're starting to show the other options less. So this is like very reasonable thing to see. And also we're seeing that it's kind of converged to exactly what a true like click-through rate is, and that's 8.5, right? So yes, and because the click-through rate is 8.5 when we're simulating, right, we're essentially having a coin that's weighted to click-through 85% of the time. So you flip a coin, if it's weighted to click-through 85% of the time, then 1 out of like 10 flips, you're gonna expect a click, right? So that's how the simulation kind of works. Yep. So yeah, in the end, we built and launched a AI-powered website that learns and optimizes its own UX over time. And this is just showing you that even with like a relatively new set of libraries, and even with like like constant changes, we're actually able to build effective products and effective like solutions already using our tools, right? And this is very cool. So this is learning a federated setting. Each user clicking on their own browser will basically update the same model, and then say the next time you go to the same website, right? The model would have been like more updated, and therefore you are constantly getting the better version all the time. So it's really using the power of federated learning. So what's next, right? Based on this, we're actually building out a new team that's working on private recommender systems. And the idea is we want to provide what people really want with the private data that stays on their devices, right? And this is actually a really good thing for users and for industry as well. So a lot of the times, we're very concerned about our data privacy. Therefore, there's a lot of information I don't want to share with big companies, right? But that data actually helps the big companies understand me better and like give me better recommendations. And that in turn will help them essentially generate more revenues, right? So this is essentially adding information and reducing the friction in the marketplace. But I do not want to give all my private data to these big companies, which means we're gonna need to essentially add some kind of differential privacy, right? And one way to do this already exists, and this is the prototype I'm working on. And maybe I'll be doing the differentially private version in the upcoming OpenMined Privacy Conference. And that is simply say, I want to essentially not listen to the user choice, but randomly generate from the distribution that I currently think about, based on the choice that the browser has randomly picked, right? So if I selected option 15, instead of actually watching if the user is clicking on it, and because we want this to be differentially private, we're just gonna say, great, you click sign up, but then I'm actually just going to sample from the distribution. And what this does is that you're essentially saying that, yes, I did see this user, I did see this reward come back from this particular browser, but we don't know if this is a locally sampled result, where did the user actually click on it. And this essentially helps by removing the identifiability of the user and their interaction and how that affects the model. So you can imagine in a kind of like a legal setting where you're trying to do some kind of survey, and maybe you're saying, hey, are you like, maybe your service you're trying to serve, the undocumented migrant community. So you send out a survey, and the first question is, are you a undocumented migrant, right? People are not going to want to say yes, because in case that data gets leaked, a lot of trouble could come for them, right? And there's like not really a good way for most people to guarantee that like there's not going to be any warrants or any like any way that data can get leaked. So, but then let's say the law enforcement agencies will only act on data they have like at least 80% confidence in, right? So all you have to do is essentially set the sample rate where you don't listen to the user interaction, but you just randomly generate from the current inferred distribution 20% at a time. So now they can no longer use this data to identify people and act on it and maybe like cause cause trouble for them. And you're still getting the same convergence and same distributions back. Because if you're generating from the same distribution, that basically means we didn't really change. We didn't really update it very much, right? So this is kind of like overview of what we're working on in relation to the worker libraries, how you can actually build real life products, what's going on with the recommender system team, and yeah, that's kind of what I wanted to talk about today. Happy to answer any questions or just talk about like OpenMined and the libraries we're working on in general. Yeah.
Cool. That's very awesome. Thank you very much, Maddie, for this this amazing demo. So please, guys, if you have any questions, do ask them in the chat. But before that, I think we have like 3 questions from the Slido part. So I'm going to ask the first question, which is, what is the RecSys team working on? So I think.
Yeah, so I kind of went into it a little bit. Basically, private recommender systems in a federated setting has to exist, because this is honestly how the companies are going to serve the customers better, how the customers can get more of what they want, and how to make sure like both parties are happy and the data is not being misused, right? So because it must exist, and because this will only be useful if people actually deploy it, we're actually working on a set of essentially developer libraries, right? That is very much informed by research. We actually have 2 goals on the team. One is that we want to build cutting-edge federated learning research tools and recommender system research tools for the research community, because the easier it is for them to experiment on recommender system that have like DP properties, the easier they can simulate various like non-IID distributions, the better the end result will be, right? So that's one side of it. The other side of it is that we want to essentially simplify and speed up the process of like research to production or research to commercialization. As in, the moment a good algorithm has been developed and the experiment works, we want to essentially directly make that available to the developers who are maybe not ML experts. They don't necessarily want to become like privacy experts or federated learning experts, but they do care about their customer and they do care about protecting privacy. So if they can then use this developer libraries we're working on, which is informed and like empowered by the latest research, then this is really a win-win situation for everybody all around, right? So that's kind of like the end goal. It's very ambitious. There's a lot of work, and we're actually actively recruiting. So if you're mobile web developer, if you're a privacy or federated learning or a recommender system like researcher or research engineer, feel free to try to join, feel free to like apply to the team and like help out. So that's kind of what we're working on. The way we're actually approaching is that we're doing a lot of like literature review right now because the team is fairly new, and we're also doing a lot of library review. The idea is that we want to see what people are already using in production and also what research methodologies people are like actively exploring, and making sure our recommender system library, our repo, is able to support both like as much as possible and as widely as possible. The other interesting thing is that the future of OpenMined, and I think either OpenMined or someone else is going to build this, and I have my bets on OpenMined, and that is a decentralized marketplace for machine learning models, data sets, and also compute, right? And obviously, privacy is very important. If I build a really awesome model, I don't necessarily want to send the model to you and leak all my data and the architecture and the weights, right? I would love to have you use it, and maybe like you can pay me in exchange, or you can give me some data in exchange. But this kind of marketplace would be very useful. Similar for data sets, I would like to share my medical imaging data set with you and have you improve your model for maybe like brain cancer prediction or something like that. But I don't want to leak my private data, like about my patients or like my medical images, things like that. So that will exist, right? And the cool thing about working on this kind of library within the OpenMined ecosystem is that this gives us the ability to essentially eat our own dog food and make sure the developer experience is good. So for example, we have plans to maybe like test out this algorithm in real life on some of our like very like infrequently accessed web pages, just to see like this is what the experiments tell us, but how does these algorithms behave in real life? Right now, a lot of if I were to like essentially make a risk statement or like a criticism of federated learning research right now, and that is a lot of it is done in the context of simulations, right? And simulations are based on researcher assumptions, which may or may not actually apply in real life. And if developers were to essentially try to apply the same algorithms and try to essentially use the same libraries, they may get like unexpected side effects because this was never like tested on real people, real users, on like real like very very different distributions of data, etc. So yeah, like that's kind of a very long answer to your question. Hopefully that answers it.
Cool. Thank you. Yes, it does. Great. So another question is it possible to use advanced reinforcement learning algorithm in the browser?
So this question is a little bit hard to answer because that really depends on what you mean by like advanced reinforcement learning, right? So the true nature of reinforcement learning is that a lot of times it either requires a lot of memory or it requires like a lot of data. And the nature of the problem is if you have a model of the world, then you need to represent that like model of the world and the related data for all the different states, and that takes a lot of memory, right? So what that means for the browser is that every time you kind of like try to update and you get a new version of the model, that's going to be a lot of like communication bandwidth, which leads to like suboptimal user experience, right? So even with this, right, like if I were to close this tab and I were to refresh, you see like a loading screen for a bit, right? And that is like, if you're a web developer, you will not be happy with that because that's a bad user experience. Imagine like, and this model is literally just like two vectors of size 24, right? Imagine if you're downloading a model with like 400 layers and like 300 watt each layer, and like that and all associated ways, that would take a long time, right? So this is why for the sake of doing a demo, we wanted to keep it like as low resource and as like quick of a algorithm as possible. Is it possible to do advanced RL? Absolutely. For example, it's easy to extend this algorithm that we just kind of talked about into a contextual bandit, where we actually take into account information that we may infer about the user and their browser and maybe their device without compromising their privacy. It's also possible to make this more advanced by increasing hierarchy. And hierarchical reinforcement learning is something that deep learning people do, but also applies in this case. And I think the most important part about doing hierarchical RL is that it just reduces the search space, right? So what that means is instead of having a flat list of these 24 options, which goes like black hero background, the buttons in the hero, the arrow, and then blue color, and then black and the hero and arrow and white, like basically a flat list of 24. It's just going to say hero background, black or gradient, etc. This will allow you to both learn interactions And also it will reduce like how much data you will need to quickly figure out which options are best or better, right? There are also like, ways of extending this algorithm into essentially something that predicts a smooth value by essentially using like Gaussian conjugacy. So these are all the things that we're working on. Yeah, so is it possible? Yes. It really depends on what your definition of dense is. And I would encourage you to think about the data and also the compute requirements for the browser use case. Yeah,
Cool.
and this
Thank
also
you.
actually, and just to add to that, this also applies to the mobile devices because like as powerful as our cell phones are becoming, they're not as like powerful as the AWS instance. So yeah.
Yeah, true, very true. Okay, another question is, what are the use cases for using RL in the browser? I mean, I think other use cases.
Yeah, so what like when you ask these kind of questions, I would like to think about like what is different about the browser and how that affects its compatibility with RL, right? We just mentioned two factors. One is that it has low resource, and one is that it has essentially like user experience requirements, which are actually like constraints, right? So that limits RL use cases that would be suitable. But then what else is interesting about a browser is that, like, I don't know about you, but I spend a lot of time like in browsers. Like this is actually a clean version that I showed you of my Google Chrome. But if I were to show you the other version, there's like pretty much like 40 tabs, all kinds of different websites. Even when I'm on my phone, I'm using my browser to do things. So the browser is a really rich and interactive environment to collect data and learn about the users, right? And this is actually really great for a recommender system kind of setting, or even just like for federated learning in general, because data just like makes everything better. So that is like essentially a different way to think about what use cases like will be good for IL in the browser. So yeah, like it's a little bit hard to like answer that question. So what data that exists in the browser that you can essentially process locally and keep private, that would be like a good use case. So one example would be, let's say and this is an idea by a team member. His name is Boba, and he will be giving another talk soon. For example, like if I'm typing and I have a certain typing pattern, right? And I use emojis in certain ways, you can actually figure out, hey, the distribution between what I usually see and what this user is currently doing has changed. And that can mean this user like had their computer hacked or their like their browser accounts compromised. And then if you do notice this kind of change, and let's say it's like significantly enough, you can say, hey buddy, really cool. Can you just like re-log in again just to make sure it is actually you, right? So that would be like a simple use case that would also work in the browser. And I think that model actually wouldn't take a lot to compute either. So yeah.
Cool, thank you. Okay, so there is Andrew's question who is asking, does this work for JavaScript-based mobile apps as well?
Yes, 100%. So like if you like so the library we're actually using is actually TensorFlow JS. So anytime you can use the TensorFlow JS environment, it would basically work. So you can imagine like getting this to work for like Electron apps and etc. And yeah, so there's a lot of like different use cases that could already be deployed right now. Yeah, and I'll go into a little bit of detail, and I think some of the other people already did, and especially if you're interested in JavaScript, tune into the next AMA because the team lead Bova, who's working on SwiftJS, is going to be giving a talk. What happens is we turn the plan into a list of operations, and then we then get that hydrated on the TFJS like environment, and then that kind of executes and then reports back, right? So there's a lot of like intricate engineering, but we did make it happen, so it's pretty cool.
Cool, great. Another question is, how soon can this be used in production by companies? Do you have like any?
Like this particular algorithm, you can already use it. I'll send you essentially the link to the notebook that talks about the plan. So give me 1 second. And in terms of like the actual library, like working with OpenMined repos are not different than working with any other like open source repos. They are a lot of changes because this is like driven by volunteers, and there may be bugs, but that pretty much is given anytime you use, any kind of library developed by other people. So like we actually have quite a lot of like partners who are startups or industry partners who are working with us and developing like tools and like services and even products on top of OpenMined already, right? And sometimes if they do hit a snag and see a bug, then our community is there to like try to make that happen for them and try to like fix the problem for them, and that in turn helps us like get better, right? The whole idea is that like try to eat our own dog food by ourselves, but also with other people. And the quicker we kind of like learn about people's use cases, what kind of issues they're facing, how we can make the experience better for them, the faster this gets better. So if you really want this, like please take it for a spin, play around, implement a little demo. We're happy to help. We're happy to like provide technical advice to help make it happen for you. And if you're really needing a feature and it's missing, please submit an issue and we will like get to it as soon as possible. Yeah.
Cool, great. So I think you're going to share something. If you want, you can post it in the comments. The notebook.
I somehow put into the private chat. I don't know if you can help me like move that
okay.
over.
Yes. I'll share it. Okay.
Yeah. Cool.
This is the private notebook. Cool. So another, I think this is the last question for today. So someone is asking, how can someone interested like in joining the team apply to join?
Great question. So I know there's a like a Google Pages. Let me see if I can find the page for you. Yeah, I think I found it. So here's actually like a list of all our teams that are like actively recruiting, and you can look at what each of the teams is doing, and then like sending an application. It doesn't hurt to sending applications for multiple teams, but I encourage you to really like look around the repo and make sure like you know like the one that you really want to work on, right? Because usually that just leads to like better learning for people who are joining us and more like velocity of development for the teams. So yes, and then if you're specifically interested in recommender systems, great time to be joining. We're actually just starting up. We're doing a lot of like team education and like really digging into things. And you're joining at a stage where you can have a tremendous impact on the tools we provide to other devs, right? So that will be under Federated Learning, and then you can make a note to say, hey, I want to join, the recommender systems team, etc. But if you apply for other teams or you want to join other teams, no hard feelings. I still support you and I still love you. So go ahead. Yeah.
Cool. So I think there is another question, if you don't mind.
Yeah.
So is there any security breach possible? I think if we use the reinforcement learning model.
Yes. So the benefit of having like differential privacy is that even if the data breach happens, you hurt less, right? And you suffer less damage. So in the case I was talking about earlier, like you're trying to provide services for like essentially underserved migrants and undocumented like people or whatever. And let's say you keep that data in AWS and one of your devs like didn't secure properly or something happened, and let's say some government agency got into it, right? At that point, like they can say, oh, look at this list of people who said they were like undocumented, right? Let's go get after them. By the time this gets to court, then the defense could be, listen, that data, we don't know if it's actually like a real selection or not. It could actually just be a random selection made locally in the browser, right? Or locally on the device. So you actually have no no right to be pursuing this. Obviously, there's some flaws in that analogy because for example, by the time you already know the list, they're kind of already exposed, right? But yeah, like something similar would apply. So let's say in the medical imaging setting, right? Like if you kind of already added noise to your data locally, by the time the data gets to the server and is like being computed on, it doesn't necessarily hurt the ML algorithm very much in terms of like improving its accuracy, but the data is already it's looking at is already noised up. So that would basically protect like a patient's like detailed information and privacy and etc. So is it possible to have security breaches? Yes. this is going to help by making it suck less.
Yeah, cool, great. Okay, so I think we have. Okay, I think there is another question. So if you use the reinforcement learning model to change UI as per user, is there a possibility of any kind of security breach? I think it's the same question, right? Or any other case apart from UI? I think, yeah.
I kind of also like already answered that question, but like even in the UI case, there's potential problems, right? For example, like I can set up a DDoS kind of situation. I can like repeatedly go to the site and click on the options that are really ugly, maybe the ones that are like all black, right? Or like all grayed out and like no colors and the buttons really small. And if I keep doing that, and if like, you know, the grid network wasn't built to be able to identify that, then the model will drift towards the bad option. So that would be one way to attack it. In fact, like adversarial attacks and defenses and vulnerabilities in the federated learning ecosystem is actually like a very big area of research and a huge research topic. So if you're interested in security, 100% look into that. There's a lot of good work being done, a lot of good work we still have to do, and this is a very important thing, right? But we actually currently have a setup that reduces the probability of having these kind of like, you know, essentially like civil attacks or DDoS attacks happen. And that is, you may see that in the notebook. There's some, you know, some information, etc., about like JSON web tokens, right? So right now, this is how we're able to identify each worker, aka the browser, who's applying to join a model training cycle, and we can say, hey, like, has this person joined too many times? And we have ways of like preventing that. So if you were to look at these server configs, and by the way, this is just like our first version, and this is currently being reorganized. It will be much easier, much simpler to work with very soon. But for example, we have random pool selection, right? That means like even if you apply, you may not get selected because we only need 20 workers and like 200 apply. Your probability of getting selected is like 1 out of 10, right? So it will be much harder for you to execute a DDoS attack or even civil attack. And then the other thing is like do not review user until cycle 20. What this means is that you can only join once every 20 cycles. So you cannot participate in the first cycle, select a really ugly UI, click on it, and then join the next cycle and do that again and again and again, right? So there are definitely mechanisms that are already built in because we did think about these considerations and we are definitely concerned about them. The other thing I want to mention is that OpenMined is working on some essentially some technologies and repo related to identity. And the importance of identity is that, especially like self-sovereign identity, is you get to control like what information about you reveal. The idea is that you just need to know I am who I say I am, but you don't need to know my full identity, right? And then what that allows people to do is that we would be able to like essentially identify users, but not compromise their like anonymity. I hope I pronounced that right. So these are all like different like ways we're trying to address these kind of problems.
Cool, great. Thank you very much, Maddie. That was awesome, very awesome to have you today with an open mind. So I think this is the last part of our AMA. Thank you very much, everyone, for joining, and see you in the next AMA. Bye-bye.
All right, cheers. Thanks for joining.